For our next story, we stay in Australia, but we go a little bit south. We move from Sydney to Melbourne. And we're going there to hear from Jason Cotton, the Program Director at Intelligent Water Networks, also known as IWN. Now, you might recall that I last spoke to Jason in September 2023, when he shared tantalizing details about a project that they were about to undertake, looking at turning biochar into batteries, or rather into supercapacitors, but the alliteration isn't quite as good there. Now, the Biochar to Batteries project has explored the feasibility of using biochar, derived from biosolids, as the active anode material for a sodium-ion battery and for supercapacitors. The project's been led by Barwon Water and has brought together a diverse consortium, including Deakin University, RMIT, the City of Greater Geelong, the water sector partners, which include Intelligent Water Networks and South East Water, and the Department of Energy, Environment and Climate Action, a whole host of the great and the good. The project underscores the water sector's potential role in the burgeoning energy storage crisis actually. It also promotes circular economy initiatives and creates new market opportunities for those utilities that might have lots of biosolids that they want to convert into biochar. So here is Jason sharing some more.
Jason, last time we spoke, you told me about a project you were doing in Australia on biochar and pyrolysis, and you teased us at the end. You said one of the things we're going to look at is, will the biochar be useful as a capacitor? And I was like, what did you mean? A capacitor? Biochar and batteries? What's this? And you promised that you'd come back and tell us about it when you got the results. So tell us about it. What was the project? Take me back a step, and what was the project?
Sure. Okay, Piers, so what we're doing is we're converting biosolids to biochar through a fluid bed pyrolysis unit, and it's a first of its kind unit that has been invented here by RMIT University. So we did some trials back in November where we got a variety of feedstocks. We got pure biosolids, we got biosolids that was blended with canola straw and pelletized, biosolids that was mixed with FOGO and pelletized, and we put those through the pyrolysis unit. And this was a brand new Mark II pyrolysis unit, about $1 million worth that we'd spent on this. And we then looked
at really nice bed. It's got no moving parts and things like that. So that's one of the
Yeah, absolutely correct. Yeah. So, and what we looked at was the characteristics of the biochar that resulted from those different blends at a number of different parameters that we were looking at, time and temperature and various other things. And also we did about 300 different analytes looking for PFAS and pharmaceuticals and all sorts of organic type products, contaminants as well. So this was quite an extensive trial run over a number of weeks here in Melbourne. So the results, it's great news. We were able to create biochar with different characteristics, different pore structures, etc. In terms of being able to use them for batteries, we are into the next phase of that project. So we actually won an R&D Excellence Awards here for that project back earlier this year in February, which was great. And so
the char can be used as a capacitor. What sort of things can it power? What are we talking about?
So biochar to batteries is actually, there's two sides to that project. The first one is to make anodes for sodium-ion batteries. We have been able to make a prototype of that, and that's actually what we won the Excellence Awards for. So they go into batteries that power things like mobility devices and wheelchairs and create a larger and longer lasting power source. The around the edges kind of approach, the blue sky, is the supercapacitor. And the supercapacitor is a device that goes into, say, a laptop computer or a tablet computer, and it gives a very short burst event of powerful energy. So when you press the start button and it immediately starts up, that's the supercapacitor at work. And we have been able to make a prototype that does work and does have those characteristics. So the next stage is now, how do we turn that into a piece of electronics that we can put into a laptop?
Now, of course, it's technically possible. So this is great that it's yes. Is it economically possible? Does it make sense? Because there's all sorts of things we can technically do. We can get to the moon. we're not all going to go there because it's just. Does this really make sense from an economics and sustainability perspective?
Yeah, it certainly does. So there's a number of aspects to the economic analysis. One is this is a carbon sequestering exercise. So this is carbon that we are recovering from organics that exist. So we're not mining the carbon or creating that carbon from virgin sources.
Because the anode need to be high quality carbon in the first place, wouldn't they?
That's correct. It would be a graphite or some other type of product, carbon product. And so that's the first benefit. The second one is that essentially this is coming from waste. So it's a circular economy exercise. So we are creating these carbon sources quite cheaply and able to use those. So we're looking, and here's another teaser. We're going to do a trial later this year and early next year that looks at creating a biochar that you can turn into powdered activated carbon for drinking water treatment. But anyway, I'll leave you with that.
And we're going to come back to that one. That's time around. Jason, it's always a delight speaking to you, and thank you for that little update, and thank you for the teaser for the next time. I'll talk to you in a few months' time, no doubt.
You're very welcome, Piers. Thanks for having me along. Cheers.
Bye-bye.
Thank you for that, Jason. Over the coming months, we'll be revisiting Melbourne to hear how Jason and the team at IWN are getting on with their Innovation Festival. Now, if you're an innovator, supplier, consultant, contractor, hell, even if you're a utility and you have an interest in developing opportunities in Australia, then this is going to be something you want to get involved in.